So what we have learned last lesson is about all of these formulas. I give you like full proof on those formulas and how to find those 5 things, which is very important for probability. There are mean, variance, standard deviation, mode, and median. Okay, there's a particular way of finding each of them. Okay, and we have the following question here. This is a graph, like a discrete probability, by using a graph to show that. Okay, using graph to show the discrete probability distribution. So the way I like to do this type of question is to turn that back into a table. So everything I worked about discrete probability is turned that into a table, and everything is quite easy and clear to see from the table. I don't really like to see the graph, but you should have the ability to read the graph. So first of all, I will just set up a table here. Okay, so 0, 1, 2, 3, and 4. We have x and probability capital X equals to lowercase x. Okay, capital X equals to lowercase x. The value I can take for x is 0, 1, 2, 3, and 4. The probability I can read, well, from 0 there's no values, so it's basically a 0 probability. You don't really need to write that, or you can directly start from 1. So at 1 you have 0.2, at 2 you have 0.3, at 3 you have 0.4, at 4 you have 0.1. So you can check it by adding up all of that. That must give you 1. So first of all, to check if anything wrong with the question, or like if it's a correct question. So 0.5, which gives you 1.0. So this is a discrete probability distribution. So I will find the expected value. So the expected x equals to 1 times 0.2 give you 0.2. 2 times 0.3 give you 0.6 plus 1.2 plus 0.4. You times them individually and add them together. So you have 0.8 plus 1.2, which is 2.4 should be the answer. That's the expected value for expected x. Okay, for expected x. Can you see like we have 2.4, which is not a possible value for x. That's alright. Okay, that's alright. So next one is talking about the median. We see where's our 0.5. 1 and 2, the probability add up just give you 0.5, and the other two give you 0.5, which means the median must exist in the middle of 2 and 3. So it's the average of 2 and 3, which gives you 2.5. Which gives you 2.5. And the next one is talking about the mode. Talking about the mode. So the mode is the x value has the largest probability. So 0.4 is the largest probability, so mode is just 3. Okay, mode is 3. Mode is not the probability, the mode is the x value. So sometimes like students answer 0.4, which is incorrect. We need the x value for the mode. And we're looking for x squared, expected x squared. So we have another line to write x squared. We can't say it's expected x and then square that value. It's not 2.4 squared. So the way we calculate that is to find the x squared value and finding the probability of x, like the probability of getting x. So start from, I don't really need that line, it's annoying. So I just take that off, and I have expected x, which is 1 times 0.2 plus 4 times 0.3 plus 9 times 0.4 plus 16 times 0.1, which is the x squared value times the probability of x. Okay, the x squared value times the probability of x. So that's 0.2 plus 1.2 plus 3.6 plus 1.6. That's 2 is 1.4. That 2 is 5.2. That gives you a 6.6, which is the expected x squared. And now we're looking for variance of x. Okay, again, variance of x got two formula. One of that is expected capital X minus the mu squared. We're trying to find the expected value for all the x, how much is away from the mean. Okay, that's the first way of doing that, but we seldom taking this procedure to work on that. Because to work on that, I need to find all the values for x minus mu squared. I need to list another line, like at the bottom on the top, which is x minus mu squared. And we have another formula, which is expected x squared minus mu squared. Expected x squared minus mu squared. This formula is good to use in this question because I know what is expected x squared and I know what is the mu. So what I will have is 6.6 minus 2.4 squared. Okay, 6.6 minus 2.4 squared. These are two values I find out before. So, okay, I will just use calculator. 6.6 minus 2.4 squared. That gives me 0.84. This is a pretty small value, which means the data are all quite close to the mean. Okay, quite close to the mean. Everything we have 1, 2, 3, 4, and the mean is 2.4. They're not quite far away from the mean. So we have a relatively small value for our variance of x. Next one is standard deviation. Okay, standard deviation, we use the symbol sigma. Okay, it's like O with a bar on top, which is sigma. We have this sign to represent standard deviation. Every time you see this sign, you know the standard deviation. This sign will be used for all the probability questions. Okay, it's all the same for the probability. So that's the square root of variance x. And that equals to the square root of 0.84. Square root 0. Oh, sorry. 0.84. Okay, I have about that. Let's give two decimal places, which is 0.92. Okay, 0.92. But later on, if we use square root variance, we need to keep exact. If we want to use sigma again, we need to keep exact. We're not carrying errors to later on questions. So we will use square root 0.84 for the following questions. Expected 4x plus 1, which is a linear transformation. The formula just can directly apply. Is 4 expected x plus 1. And that's 4 times 2.4 plus 1. 9.6 plus 1, which is 10.6. Which is 10.6. Okay, and I have 1 over x. I have 1 over x. So I will find 1 over x value first. I will have 1, a half, a third, and a quarter. And times the probability. So 1 times 0.2, half times 0.3, third times 0.4, and a quarter times 0.1. So that's a 0.2 plus a 0.15 plus, well, it's not really divisible. I will turn that into fraction. So that's 1 of 5. 0.3 is 10 out of 3, which is 3 on 20. And 0.4 is 2 on 5, which is 2 on 15. Plus 0.1 is 1 on 10, so 1 on 40. Okay, so I'm looking for the 120. 120 will be the lowest common denominator. So 120, 24, 120, that. 120, I'll times 8 on that, which is 16, and 120 and 3. And you just add all of them up. 19 plus 18, 36, 37, 37 plus 24, which is 61. 61. So it's 61 on 120. Okay, 61 on 120. So I'll keep it exact. Well, like most of the time, it will ask you to go for 2 decimal places, so you just put that into the calculator and find the approximation value. Okay, next one, variance, and it's a linear transformation here. Okay, variance, and it's a linear transformation. So the formula is we just don't think about the constant here. Just think about the constant, not the coefficient for x, which is 3, but it will be 3 squared variance of x. For expected value, variance, and standard deviation, all the linear transformation will be slightly different. So that's 9 times variance of x, which is 9 times 6.6. 559.4. And the next one is standard deviation. We just ignore the constant as well, but it's not squared for that value. It's the absolute value for the coefficient. It's the absolute value for the coefficient, which is 4 times square root 0.84. Remember, standard deviation is square root 0.84, so we use 4 times that. So times that by 4, 3.67. 3.67, yep. Oh yes, it's the expected value. Yeah, thank you. That's 0.84. So 0.84 times 9, 7.56. Yeah, that's correct. Okay, so that's how we do this type of question. So this is the really basic part. Okay, this is the really basic part. All the discrete probability will be able to calculate by this way. This is the most difficult way, I can say. When you have some special distributions, like when the experiment follows some order, there will be some patterns. We can have an easier formula to calculate expected value variance, which I will show you later in next lesson. But this is the basic, okay, this is the basic. Every time you forget what to do, you can just use that formula to work out the expected value, variance, mean, standard deviation, and the mode. Okay, so this question just fully exercised everything from the previous page. So that's include every single knowledge. For the following 2 questions, again, example 2 is a good one, especially part A. Especially part A. So you definitely need to try this example. And all the rest will be pretty much the same. For example, let's have a look for E. I'm not going to calculate the value for you, but I will show you what's variance negative 1x. So that will equals to negative 1 squared variance of x. And that will still be equivalent to variance x. So variance negative x will be the same as variance of x. And we have variance 3x plus 1, which is 3 squared variance of x. And that's 9 variance of x. Which variance of x you should find before already, which is D. Okay, which is D. And well, when you're trying to calculate variance of x, you will use the expected x squared minus expected x, which is the mu, and then square that value. You have mu here, okay, mu is given to you here, and you need to work out expected x squared by yourself. And standard deviation, which is easy, you can work out that. And for h will be absolute value of negative 2, and then standard deviation x. Still ignore the negative 1, and we have 2 standard deviation of x. Okay, so after you work out the mode, median, standard deviation, and variance, you can easily find out all of these values. It's just a transformation applied to probability as well. So it's a linear transformation. Right, so that's what I'm going to talk about for this chapter, and the following question will be very much the same, but is giving a probability distribution equation, like give you a mass function to see the probability. So what I will do again, will still set up a table. So table is the easiest way to think about things. I still set up table X, probability X equals to X, and then we think about all of that. So -4, -3, -1, 0, 1, 2, 5, and 6. And then you will use the mass function to calculate the probability for each of that. And then going back to the same way of calculating mode, variance, median, standard deviation, all of that. Okay, so everything will turn back into a table, and you can from the table to work on the required things. Oh, well, it's not necessary. If you think like you can directly work from the mass function, it's also fine. It's just like when you have the table, it's very explicit to see all the probabilities. Okay, so that's pretty much all for what I should talk about for the first chapter, like chapter 13. So the important thing is just this page. Okay, page 7, which is really, really, really important. The whole page 7, everything I have talked about in this page, you need to know that. Okay, nothing extra. So everything I talk about, you need to know here. And then the next thing we talk about, like we get a little bit revision on, which is the hypergeometry distribution. This talks about more about getting probabilities without replacement. Okay, probabilities without replacement. That's the equation, how we work on that. And we learn how to set up distribution table. Like, for example, I have how to set up this table. You should be able to know how to set up a distribution table by yourself according to the experiment they're given to you. And the thing we learn, the first thing we learn is how to check the conditions, okay, for probability distribution. Okay, so when it will become a discrete probability distribution, you will use those two conditions to talk about that. Okay, that's pretty much all for this chapter. It's a fundamental like knowledge for the later on chapter. So you need to know this. Okay, so I will finish up that one. I'll give you the other two questions to do by yourself, and we'll start with chapter 14 today. Okay. Everyone. Well, I'll start.